Alright, so I'm going to talk about one of my favorite topics. It's called the counting principle. And there's a couple of different things. There's tree diagrams, and well, I'm going to do these four topics. I highly advise you pause when you need and take notes. Alright, so the counting principle basically says if there's something that you can do m ways followed by something else you can do n ways, the total number of possible ways of doing something is m times n. And I'll give you an example. So you go out to dinner and you have some appetizers. Let's say you have 2 appetizers, you have 3 entrees, and you have 2 choices for dessert. It looks something like this. For appetizers, let's say you could have had soup or salad. For your main meal, you could have had the fish, the veg, or the meat. And fish, veg, meat. I'm just going to abbreviate. And the last 2 choices you had, say, creme brulee or tiramisu. Ooh, I love tiramisu. So I'm just going to abbreviate and say CB. I'm going to say TI, which is the same as titanium, which I don't want you to get too confused. So you end up with, let's see, how many possible choices? Well, this is one possible choice, as is this. As is this. That actually looks like an F. Let me change that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait a second, I missed one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. And sure enough, take a look. You have 2 times 3 times 2, which is 12. And you might be saying, really? Is that really true? Well, sure. Because let's say I want to have the soup and I want to have the tiramisu. How many different ways I gotta have that? Well, I could have the soup and the fish and the tiramisu, or I could have the soup, and that's one way, and the soup, the veg, and the tiramisu. That's another way. And I could have the soup and the meat and the tiramisu, and that's 3 different ways. Well, yeah, that's pretty easy to see. And you say, well, isn't soup and fish and tiramisu close enough? No, it's not, because creme brulee and tiramisu are 2 different things. Anyway, so that's basically the idea. I'm gonna get rid of this real quick. And I'm gonna look at something else. Let's say I had to paint 3 houses. I had red, blue, and green. I said, alright, well, how many different ways can I paint the first house? So house 1, if I wanted to paint them 3 different colors, would have red, blue, green. Second would just have blue or green, and this one would be red or green. This one would just be red or blue. And then this would be red, blue, green, red, green, blue, blue, red, green, blue, green, red, blue, and green, blue, red. And these are all the possible outcomes. So the first house you have 3 different choices. Second house you only have 2 choices. Third house you have 1 choice. And that equals 6. There's a funny notation for this. It's called factorial, and it's 3 factorial. And this means 3 factorial. Alright, so I'm going to move on. Well, I'm going to stick with this topic for one more moment. If you want to take a look at names, you want to rearrange. Uh-oh, I don't know what I just did. Uh-oh. Let's go back to the pen. All right, here we go. You want to rearrange names. Let's say, or letters in a word. Let's say I had the word run. Well, it's going to be 3 factorial, which is 6, because you have RUN, RNU, URN, which is actually a word, UNR, and then NRU, and NUR. But if I had the word Peter, because the E's are the same, PETER would be the same as PETER. I'm going to say, well, I have 5 factorial, but I have to get rid of 2 factorial to account for the repetition. So you have 5 times 4 times 3 times 2 times 1 over 2 times 1. That cancels out, and you're left with 60 different arrangements, and that takes care of the repetitious E's. I'm going to do one more thing with you, and I know this has been a quick blast, and so if you need to rewatch this, or well, if you need to rewatch it, then rewatch it. The last thing is whether or not something's allowed. So if you take a look at and your book does a great job of using license plates, because a lot of license plates usually allow you to have 3 numbers, or rather 3 letters, and 3 digits. And so if they were just random and any repetition was allowed, it would look like this. And I actually don't have my calculator on me, but how many letters are in the alphabet? 26, 26, and 26, because it could be A, dash, and how many numbers are there? Well, 0 through 9 is 10 times 10 times 10, and I'm not going to imagine why I know what that is. And this is not an equal sign or a minus sign. I'm just going to, nor is it a plus sign. I'm just going to get rid of it actually. So anyway, I guess actually I could put in a multiplication sign, and that would be your answer. If repetition was not allowed, you would still have 26 chances for, or choices for your first letter, but then it'd be 25 choices, and then 24 choices. Because you can't, if you use A, you'd only have 25 choices left. If you use C, then you'd have A and C would be out, so you have 24. This would be 10 times 9 times 8. You multiply those all together, and you get all the possible, or the number of possible combinations. And that's it. So once again, I highly recommend you do watch this again, and then take some notes and see how things go. Take a look in your book.